Hi all, in this lecture we will be seeing about challenges for wireless sensor network. We are going to see the challenges one by one required in a WSN. So the first characteristic requirement is going to be the type of service. The service time rendered by conventional communication is going to be moving from bits from one place to another. But for a WSN, rather than moving bits, we are going to move the numbers. The concepts like scoping of interactions using a specific geographic regions or to time intervals is going to be more important. Hence, we are going to have new paradigms, which new interfaces and new service of inner network. The next one is going to be our quality of service. We have discussed more about quality of service, but traditional QoS metrics are not able to be applied in wireless sensor network. Still, we have quality of service with bounded delay and minimum bandwidth in our quality of service in WSN. It is important when actuators are to be controlled in a real-time fashion by the sensor network. The packet delivery ratio, which involves the relevant amount and quality of information, can be extracted at particular sinks and about the observed objects or area. Therefore, adapted quality concepts like reliable detection of events and approximation of quality is more important. The third challenge is going to be fault tolerance. Here, nodes may run out of energy or it get damaged since the wireless communication between two nodes can be permanently interrupted too. So, it is important that the wireless sensor network will be able to tolerate such fault. To tolerate the node failures, redundant deployment is necessary. Using more nodes than would be efficiently and proper manner the sensors could take. The fourth challenge is going to be lifetime. A lifetime of a wireless sensor network becomes a very important figure of merit. The lifetime of a network also has direct trade-off against the quality of service, investing more energy which actually increase the quality but decrease the lifetime. The definition of lifetime depends upon the application. A simple option is to use the time until the first node fails as the network lifetime. But we also have other options which include the time until the network is disconnected, the time until 50% of nodes have failed, and the time for the first time at a point is observed is no longer covered in a single sensor node. We have other challenges like scalability. Scalability is going to include a large number of nodes in a wireless sensor network. We need to employ architecture and protocols to scale these numbers. Wide range of densities. The number of nodes per unit area is going to give the density of the network in WSN. Different application will have different node densities. Even with a given application, the density can vary over time, space, like this. The density also does not have an homogeneous to be in the entire network, and the network should be able to adapt such variations. Programmability. Here, the nodes is not only necessary to process the information, but it have to react according to the changes in their task. These nodes need to be programmable and their programming must be able to change during the operation when new task becomes more important. A fixed way of information processing is always insufficient in WSN. The last challenge is going to be maintainability. As both the environment of a WSN and the nodes itself change, we need to monitor the health and status of the operational parameters and choose different trade-offs. When energy source becomes scarce, the network has to maintain itself and it is able to interact with external maintenance mechanism to ensure the extended operation in a required quality. We have seen various challenges about the WSN. Now, we need to realize the requirements with innovative mechanisms to overcome the challenges in the same wireless sensor network. We need to have the development and implementation of a wireless sensor networks for every individual application. So, let us now discuss few of the mechanisms involved in the same. The first mechanism is going to be multi-hop wireless communication. While the general wireless communication takes place with a direct manner from sending between a sender and a receiver, but it has few limitations. In particular, in WSN, when we need to cover over long distance, we need to have high transmission power. The use of intermediate nodes as relays can reduce the total required power. Hence, we are going to go for multi-hop communication, which will be the necessary ingredient. The next mechanism is going to be energy efficient operation. To support long lifetime, the energy efficient operation is always going to be the key technique in WSN. The option to look into include energy data transport between two nodes, the energy efficient determination of a requested information. The forming of hotspots is going to be an issue here while in non-homogeneous energy consumption. The third mechanism is going to be auto configuration. A wireless sensor network will have to configure most of its operational parameters in an autonomous manner rather than the external configuration. As an example, the node should be able to determine their geographical position only using the other nodes of the network. So, it is called as self-location. Also, the network should be able to tolerate the failing nodes and to integrate new nodes with incremental deployment after the failure happens. The fourth mechanism is going to be the collaboration and in-network processing. In some application, a single sensor node will not be able to detect whether the event has happened or what is done in the network. Hence, with several networks in a sensor, we have to collaborate to detect an event and then with the same network, various forms to achieve this collaboration. We need to have the individual sensors to be aggregated as they propagate through the network, which will reduce the amount of data to be transmitted while improving the energy efficiency. The next mechanisms are going to be data-centric networking. We have two types of centric in a particular network. One is going to be address and the other is going to be the data-centric networking. The data between two specific devices when it is equipped with one network address and the operation of such networks is called as address-centric. But here in WSN, where nodes are typically deployed redundantly to protect against the node failure, we are going to move the switch from address-centric paradigm to a data-centric paradigm by designing the architecture and more communication protocols. The next mechanism is going to be locality. Rather designing a proper mechanism, the principle of locality will always ensure about the node scalability. So the nodes which are very limited in resources like memory, it needs to attempt to limit the state accumulate during protocol processing to only information about their direct neighbors. The hope is that the network need to scale large number of nodes without having to rely on powerful processing. Hence, we need to combine locality principle with other efficient protocol design. The last mechanism to overcome the challenges in WSN is going to be the exploit trade-off. Similar to the locality principle, WSN have to rely to a large on exploiting various inherent trade-offs such as lifetime and other node density. So in node density, it depends upon the application, the deployment, the node failures at runtime. The network density can change considerably. Hence, the protocol we need to handle in a different situation based on the location too. Harnessing these mechanisms, we need to have the efficient wireless sensor network which involves various programs and from data-centric view and allows the concepts like required accuracy, trade-off or scoping.